Am I the only one that didn't know metal feels colder than wood because of thermal properties? Let's break it down. When you touch a metal surface, it feels colder than wood, even if both are at the same temperature. This is because metal conducts heat away from your hand faster than wood does. The sensation of coldness is due to the rapid transfer of heat from your skin to the metal. Wood, on the other hand, is a poor conductor of heat, so it doesn't draw heat away from your hand as quickly, making it feel warmer. This simple observation is a great starting point to understand the fascinating world of thermal properties. Thermal properties of matter describe how substances handle heat. These properties determine how materials absorb, transfer, and retain heat. Understanding these properties is crucial in various fields, from engineering to environmental science. For instance, in construction, materials with specific thermal properties are chosen to ensure buildings are energy efficient. In everyday life, these properties affect how we cook, how we stay warm, and even how we design electronic devices. There are three key properties: thermal conductivity, thermal expansion, and specific heat capacity. First, thermal conductivity. This property is all about how well a material can transfer heat. It's a measure of a material's ability to conduct thermal energy. Materials with high thermal conductivity, like metals, are excellent at transferring heat, while those with low thermal conductivity, like wood or plastic, are not. This is why metal objects feel colder to the touch than wooden ones, as they draw heat away from your skin more efficiently. This is how well a material transfers heat. Thermal conductivity is a critical factor in many applications. For example, in cooking, pots and pans are often made of metals like aluminum or copper because they can quickly transfer heat from the stove to the food. In contrast, materials with low thermal conductivity are used for insulation to keep heat in or out, such as in building walls or thermal flasks. Metals like aluminum and copper have high thermal conductivity, meaning they transfer heat fast. This property makes them ideal for use in heat exchangers, radiators, and cooking utensils. Copper pipes are commonly used in plumbing because they can efficiently transfer heat from hot water. Aluminum foil is used in kitchens to wrap food because it can quickly transfer heat, helping to cook or keep food warm. That's why your metal spoon heats up in your coffee. The heat from the hot coffee is quickly conducted through the metal spoon, making it hot to the touch. This rapid heat transfer is a direct result of the high thermal conductivity of metals. Next, let's talk about thermal expansion. When materials heat up, they expand. This phenomenon is known as thermal expansion. As the temperature of a material increases, its particles move more vigorously, causing the material to expand. This property is crucial in many engineering applications. For example, bridges and railways are designed with expansion joints to accommodate the expansion and contraction of materials due to temperature changes. Think about a hot summer day when train tracks can bend. The intense heat causes the metal tracks to expand, and if there isn't enough space for this expansion, the tracks can warp or buckle. This is why railway tracks are laid with small gaps between sections to allow for thermal expansion and prevent damage. Materials like glass and metal expand more noticeably. In laboratory settings, scientists measure the expansion of different materials to understand their thermal properties better. For instance, glass can crack if it expands too quickly when heated, which is why special types of glass like Pyrex are used in cookware and laboratory equipment. These materials are designed to withstand rapid temperature changes without breaking. Finally, specific heat capacity. This is the amount of heat needed to change a substance's temperature. Specific heat capacity is a measure of how much energy is required to raise the temperature of a given amount of a substance by 1 degree Celsius. Different materials have different specific heat capacities, which affects how they respond to heat. Water has a high specific heat capacity, so it heats up and cools down slowly. This property makes water an excellent coolant and a stable environment for many chemical reactions. In cooking, it means that water takes longer to boil but also retains heat for a longer period, making it ideal for simmering and slow cooking, perfect for regulating our climate. The high specific heat capacity of water plays a crucial role in Earth's climate system. Oceans absorb and store large amounts of heat, helping to regulate temperatures and maintain a stable climate. This is why coastal areas tend to have milder climates compared to inland regions. And there you have it. Understanding the thermal properties of matter helps us make sense of the world around us. From the materials we use in everyday life to the natural processes that regulate our planet's climate, these properties are fundamental to many aspects of science and engineering. Thermal properties of matter in a nutshell. Stay curious, science enthusiasts. Keep exploring and learning about the fascinating world of thermal properties. Whether you're a student, a professional, or just someone with a keen interest in science, there's always more to discover. So next time you touch a metal surface or watch water boil, remember the amazing thermal properties at work. Stay curious and keep exploring the wonders of science.